All right, so in today's video, we're going to be looking at imaginary and complex numbers. So an imaginary number is called imaginary because it technically cannot exist, but we still need to look at it in simplification ways. So imaginary is represented by the letter I, and that means that I'm taking the square root of a negative number. So the most basic negative value that we're going to be taking is -1. So the square root of a -1 is represented by the imaginary I. We also have what we call complex numbers. Complex numbers are when we have imaginary and real numbers mixed together. So we're going to look at both of those, and we're going to talk about how to add and subtract those. So when I'm looking at imaginary numbers, so the question is what is an imaginary number? So when we square or when we raise any negative value to an even exponent. So let me give you an example. So let's say I take -2 and I raise that to 2. That means -2 times -2, that will always turn into a positive number. I could raise -2 to the 4th power. So that would be -2 times -2 times -2 times -2. So that's going to be -2 times -2 is going to give me +4. +4 times -2 is going to be -8, and then we have -2 times, or -8 times -2 is going to be +16. My point to this is no matter what even exponent we raise our number to, our negative number to, it will always turn into a positive number. So if I take a negative number and I raise it to an even exponent, it will always turn into a positive number. So the reason that we have an imaginary is because taking the even root of a negative number cannot exist. Why can it not exist? Because if I take the square root of a square, that is the inverse of the other. So if I have x squared, the inverse of x squared is taking the square root of x. So if I square a negative number, it will turn positive. So I can't take the square root of a negative number because it never existed to begin with. So when we talk about a negative number in a square root is considered to be imaginary. And that's the reason we represent it by the I. So that I is going to happen when I have an even index. So an even index is the number inside of the radical, and if that number is even, then I will never have a negative number, so it produces an I. Okay? Now, how do we deal with I? So I'm going to talk about some ways to simplify this. So if I'm talking about I, so again, it's going to be lowercase, and if I have that, it's going to always be the -1 square root. So if I have the square root of -1, that is going to represent that imaginary number, I. So what happens if I take and I square it? Well, if I square a square root, those are inverses of each other, so they will eventually cancel each other out and equal -1. If I have I cubed, that means I need to break this down further. So we already know that if I have I squared, that it equals -1. So I'm going to break it down in such a way that I can simplify it easier. So I know that I have I squared, which is going to be the square root of -1 squared, times that one I left over. Okay, because remember right here, this is I squared. So I squared times I will give me I to the 3rd power. But I also know that when I did this just a second ago, that this equaled -1. Okay, so technically this is going to be -1 times I. Well, -1 times I is going to produce -I. And I'm trying to get used to writing my I's a certain way so it doesn't look like 2's. So that's going to produce -I. All right, so what about I to the 4th? Well, I to the 4th is simply I squared times I squared. Well, we already know I squared is going to equal -1 times -1, so that's going to produce and make it +1. Well, then we have I to the 5th. So we know I to the 4th, so this is going to be I to the 4th times I. So I to the 4th is 1 times I, which is essentially going to produce just I. We're going to start looking at these patterns, and we're going to look at how can we simplify these, especially with much larger numbers. So I'm going to show you a pattern here. So we just determined these. We determined that I to the first power is just I. I to the second power equals -1. I to the third power equals -I, and I to the fourth equaled 1. We also just determined that I to the fifth equals I. Now, I'm going to tell you that I to the sixth, if we simplify that, is going to equal -1. I to the seventh is going to equal -I, and I to the eighth is going to equal 1. Now, the reason I'm doing this is because I want you to see this pattern happening here. If you can learn the first 4, then you can learn all the rest of them that you need to learn because they start to repeat itself. So I to the first and I to the fifth both equal I. I to the second, I to the sixth both equal -1. I to the third, I to the seventh both equal -I. I to the fourth and I to the eighth both equal 1. So I'm going to do this pattern again. I'm not going to do any work. I'm just going to do it based off of the repetitiveness. So it's I to the ninth. I to the ninth also equals I. I to the 10th is going to equal -1. I to the 11th is going to equal -I. And I to the 12th is going to equal 1. So if you can learn the first 4, the pattern will continue to repeat itself. Okay? So this is very important that if you can learn the first 4, it will start to repeat itself. All right, so what we're going to do is we're going to simplify this with much larger number values. So if I have I to the 17th, I need to make I to the 17th in my problem. So I think I figured all the way out to 12. You don't have to do it based off of 12. You can do them smaller if you'd like, but a lot of the times it's easier to remember them based off of the 10 value. So like if I'm doing 10, I know that equals -1. So I'm going to start with there, or I'm going to start there. So I have I to the 10th. So I need to get to 17. Well, I know I to the 7th. Also, we know one of those values. So if I'm looking at I to the 10th, I know I to the 10th equals -1. And I to the 7th, I know is -I. So -1 times -I is going to produce +I. And if you had continued that pattern, if I did 12, 13, 14, 15, and then to 16, the pattern would start back over at 17, which would be I again. So then we have I to the 99th. So again, I'm going to split this up based off of 10s and then go from there, because I always like to do it with 10s because I know 10 is always equal to -1. So we have I to the 10th times I to the 10th, and we would do this 9 times. All right, so we have I to the 10th. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, what do we have left over? Well, we have I to the 9th left over. So what do I need to do here? So in this particular problem, I know that I'm basically saying that I have I to the 10th, and I'm going to raise it to it 9 times because there's 9 of them. And then I still have I to the 9th left over. Well, that basically is telling me we know I to the 10th is -1. So we're going to do -1 raised to the 9th power. Well, -1 times -1 times -1 9 times is still going to produce -1. We also know that I to the 9th we determined was just I. So again, we have -1 times I, which is going to be, that is going to produce just -I. All right, so then we have 120. So again, if I were to do the same pattern, I would do it in 10s, but and then if I split this up into 10s, so I'm going to have I to the 10th and I'm going to raise that to 12. Why? Because I could chunk it into 12 units of 10 that I would split it up in. So we know that I to the 10th is equal to negative 1 to the 12th. That's an even exponent, so this is going to equal positive 1. All right, this is we're going to simplify. So I have the square root of negative 36. So if I have the square root of negative 36, I have an imaginary number. I know I have an imaginary number because I have this negative on the inside. So the first thing I'm going to do is I'm going to get rid of that negative, and I'm going to get rid of that negative with bringing that I out. So that's going to leave me with I square root of 36. Well, now I can easily simplify this. The square root of 36 is a perfect square, which is 6. So this is going to be 6i. So the square root of negative 36 is 6i. Same thing with number 2. So if I have that negative in front, that's going to give me I, but I have the square root of 12. Now 12 is not a perfect square, so we're going to have to reduce this down. And I'm going to use my factor tree here. So 12, I can reduce that down to the square root of 3 and the square root of 4. Okay, so I know that the square root of 4 is a perfect square. So the square root of 4, I can actually reduce this, and that's going to equal 2. So we're going to pull that to the outside. So that's going to be 2i, but I have the square root of 3 left over, because this is going to remain in my square root problem. Now, if you don't like the way that I just did that factor tree, you may have been shown differently. That's fine. You can reduce it completely down to all prime numbers. So I can reduce the 4 all the way down to 2 and 2. But since it's the square root, we need to have groups of 2 numbers. So I have a group of 2 numbers, which is 2's. So that is the reason that I now have a 2 in the front, because when I take that out, that's where I got the square root from. But I also have this 3 that was left over, and that's where that went back inside of the square root. Now, number 3 is different because it is the 4th root, so I would have to make groups of 4. However, I still have that negative in the front, which is going to turn into I. So I have the 4th root of 128. So I can reduce the 128. I can go ahead and simplify that. So I have 4 and 32. This is 2 and 2, so we're done with that one. So 32, we're going to reduce that down to 4 and 8. So we have, again, 2 and 2, 2 and 4, and then we have another set of 2 and 2. So when I look at this, I have a total of 1, 2, 3, 4, 5, 6, 7 2's when I reduce this down. But I have to make groups of 4. So I have one group of 4 here. And then I have 3 2's left over. So right here I have 3 2's left over. So my group of 4 is going to go on the outside. So that's going to be 4i, the 4th root, and I'm going to multiply these pieces back together. So 2 times 2 times 2, that's going to give me 8, goes back on the inside. All right, so now what we want to do is we want to talk about how to simplify with our complex number. So what is a complex number? So a complex number is where I have a mixture of real and imaginary. So when I'm looking here, my A and my B are my real numbers, and my I, obviously what we've been talking about, is imaginary. So you're going to learn how to combine these two together, and you can only combine them together if they're like terms. So let's go ahead and let's look at a few examples. All right, so when I'm looking at this, we're going to simplify. So I have 2i and 3i. So an example of this, let's say I have 2x plus 3x. So I can combine these together because they both have an x in common. They are like terms. So I can combine this together to make 5x. What I can't do is if I have 2x plus 3y, those are not going to be like terms because this one has a 3 and this one has a y. Same thing applies when I have imaginary. Think about the i's like the variable x. I can combine these two because I have an I and an I. So that's going to combine together to make 5i. All right, just like if I have for the next one, I have 16i minus 5i. I can subtract those because they are like terms. So 16i minus 5i gives me 11i. All right, so now we got to multiply. I know that I'm going to multiply because my parentheses are side by side here. So if I multiply, this is going to be 3 times 4 is 12, and then we have I times I is I squared. Well, we need to simplify this. We should already understand that I squared, we figured out previously, is going to represent -1. So 12 times -1 is going to give me -12. All right, so let's look at 4. Again, we're multiplying here. So we have I. All right, so let's see. We have I times I times I. So that's going to be I cubed, or I to the third. And we have 2 times -3, which is going to give me -6. All right, so we know from our previous problems, okay, you're going to start to learn these as we do them. We have I to the third power equals -I. So we have -6 times -I. So -6 times -1, technically is a -1 in front, is going to be +6i. Okay? But what I really want to focus on today is adding and subtracting. So combining like terms, but with complex numbers. And remember, complex numbers are a mixture of real and imaginary. So when I look at number 5, it's asking me to add these two together, but I can only add together what's like terms. So my like terms, so we want to write it in the format A plus or minus BI. Okay, so we want to start with just our real number that's by itself. So we have 2 and 1. When we add those together, that's going to give me 3 plus, and then my next number is going to be 3i and -6i, so that imaginary number. So 3i plus -6i is actually going to give me -3i. Now, we don't want to write minus a negative, or plus a negative, excuse me, so we're going to rewrite it, so it's 3 minus 3i. Now, for number 6, this problem alone can trip up a lot of students because of that minus sign. A lot of times they'll apply the minus to the first term, but they won't apply it to the second one. So my suggestion is to go ahead and distribute that negative. So if I distribute the negative, that's going to turn this into plus. Negative times -4 is going to be +4. Negative times -I is going to be plus I. And now I can just combine my like terms like I did a second ago. All right, so I have 5 and 4 combined together are going to make 9 plus, and then I have -2i and I. So that's going to give me just -I. Again, I need to rewrite it so it's formatted correctly, so 9 minus I. All right, so I'm going to do one more example just to make sure we're all on the same page. So if I have -5 minus 3i minus 1 minus I. Okay, so again, I have that subtraction, so I'm going to make it easier on myself and I'm going to distribute the negative. So I have -5 minus 3i plus, this is going to be -1 plus I, and then I'm going to combine like terms. So I have -5 and -1, that's going to produce -6 plus, and then I have -3i and positive I, so we have -2i. And again, I would just want to rewrite that so it would just say minus instead of plus and negative. Okay? Please don't hesitate to email if you have any questions about these examples. And I would definitely keep or make sure I've written down a list of what my I values represent to make it easier on yourself. Again, you'll start to learn them, but just make sure you know at least the first 4, and then you know they repeat after that.